So I want to remind you before we start that you should be taking notes on this because you can use it in class tomorrow. So I have up for you right now a summary of the quantum numbers up to energy level 4. And what I've written in the last two columns, instead of writing plus and minus 1/2, I've given you what the orbital names are and how many electrons they have. So in n equals 1, you have L value of 0, your m sub L value, which is your orientation, is 0 as well. So we call that orbital 1s, the 1 coming from the energy level, the s coming from your L value. That holds 2 electrons. In the second energy level, you have two possible choices. You have L is equal to 0 and L is equal to 1, which you would call then 2s and 2p. In the 2s orbital, you have 2 electrons. In the p orbital, you have 6 electrons. If we were to add them together, you have 8 total electrons. And let's see, does that fit? 2 times 2 squared is 8. So this does follow our rule about energy levels and their electrons. So we go all the way down to the 4th energy level. You have 4 possible orbital names, 4s, 4p, 4d, 4f, for a total of 32 electrons. Okay, so this is a summary. If you want to pause it here and copy this down, now would be the time. Otherwise, we're going to move on. So what we're going to be building to are orbital diagrams, which will allow us to figure out how electrons bond with another atom. So we're going to start with energy level 1, and our possible L value is 0. Our m sub L value is 0, and our m sub s, we could have a plus and a minus 1/2. So what we're going to do is we're going to draw a diagram. The first thing we're going to indicate is we're going to figure out how many m sub L values there are. There's only one possible value, so we're going to draw a line, one line because there's one value. And we're going to put down below the energy level, which is 1, and the type of orbital. It's an s orbital. Now we're going to change our electrons. Instead of writing a 1/2, we're going to write them as an arrow. Half arrow for your positive 1/2, and a half arrow down for your negative 1/2. So we could write up and down. Okay, so that says on one line we can fit 2 electrons. Let's go to our second energy level. You have 2 possible L values, 0 and 1. When our m sub L is 0, we can have a plus and minus 1/2. So again, we have 1 m sub L value, so we're going to draw one line. Put under it this time a 2s. It could have an up arrow, it can have a down arrow. When n is equal to 2, L is equal to 1, you have values of negative 1, 0, and 1. So I have 1, 2, 3 values. So I'm going to write 1, 2, 3 lines. Okay? Move that up just a little bit. Under the whole entire set, you're going to put 2p. Now I hope you see a pattern starting with how many lines and how many electrons. For every line, you can put 2 electrons, up and then down. Remember, when we added our quantum numbers, we had plus 1/2, plus 1/2, plus 1/2, the school bus rule. So we can add electrons to this orbital in the same manner, up, up, up. But remember, we can always add our negatives. So we have 6 total electrons. If we follow the school bus rule, we would go down as well. All right. Let's do our third energy level. 0, 1, and 2. So 0, negative 1, 0, 1, negative 2, negative 1, 0, 1, 2. Let's extend this up a little bit. I'm going to stop writing electrons right now. So I'm going to draw a first line saying it's a 3s orbital, positive 1/2, negative 1/2. I'm going to go on to my L equals 1. I have the negative 1, 0, positive 1, called 3p. Up, 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 positive 1, positive 1, positive 1/2, negative 1/2, negative 1/2, negative 1/2. So we would do this however many times you need to fit up to so many electrons. So this would fit us up into having 18 electrons right now. All right, let's continue on to our L equals 2, so we need 5 lines. 1, 2, 3, 4, 5. Underneath all of that, you would write 3d, because L equals 2 means a d orbital. Again, half, 1 half, 1 half, 1 half, 1 half, down, -1, -1 half, -1 half, -1 half, -1 half. So the pattern continues through the 4th energy level, 5th energy level, etc. This does get a little bit time consuming, but your quantum numbers are the basis for this. So where is this going to lead us? Tomorrow we're going to work on how we would add it for specific elements. But overall, this is what you're going to achieve. Okay, on the left here, right here, I'm going to jiggle it. This is how the orbitals line up according to their measured energies. So we start at the bottom. We have 1s. Then we go 2s, 2p. So quantum numbers we're following, 3s, 3p. But then we have a little bit of a shift. The measured energy that comes first is a 4s orbital. That means our quantum number 4 is actually being measured before we reach the end of our 3rd quantum number, 3d. So why did this switch? Remember, quantum numbers are mathematical calculations. When these measurements were taken, the energy levels that these electrons had, starting in the end of the 3rd energy level, n equals 3, they started to be adjusted, or they started to be different and varying just slightly from the actual quantum number calculations. So we have to account for that. We want to use the true measurements that scientists were using. So we do adjust, and we do put the 4s orbital, which has a slightly different, it comes after in quantum numbers, but that is going to actually come before our 3d orbitals. We're going to get to the top over here. We're going to learn in class what these all mean. This is our shortcut, kind of like when we wrote quantum numbers, we put them into the coordinates. This is going to be our shortcut instead of writing orbital diagrams. The orbital diagrams are the boxes with the lines. All right, so we're going to pick up from here. It might be handy as well to study your electromagnetic spectrum for your pop quiz on Thursday.